Hi all. Today we're going to go through part 2 of topic 7, calculations involving limiting reagents. In our previous lesson, we were given the amounts of two reactants and then asked to solve for the amount of product being generated. First, we needed to identify the limiting reagent and then use the limiting reagent to work our way across using mole ratios. In these problems today, instead of being given the amounts of two reactants, we're going to be given the masses of two of the reactants. And this is going to add a few extra steps that we're going to need to do, but the process is going to be similar. So first, we need to convert those masses using the molar mass to an amount of reactants, using N is equal to mass divided by molar mass. From there, we're going to use mole ratios to identify our limiting reagents, just like we did in our last lesson. The limiting reagent will determine how much product will be generated. So we're going to use the limiting reagent and mole ratios to convert and identify how much product will be made. And once we know the amount of product, we can go and use the molar mass of that product to identify the mass of it that will be generated. So let's try a sample problem to work our way through this. So in this question, it says methanol, which has a formula of SCH3OH, can be made using a synthesis reaction involving carbon monoxide and hydrogen. So we have CO, which is carbon monoxide, plus 2H2, which is hydrogen gas, making methanol CH3OH. And the question asks, what mass of methanol can be produced when 9.8 grams of carbon monoxide and 1.3 grams of hydrogen are mixed? So in here, like we did with the last problem, we need to write out our balanced equation and write out what's given. And we're going to be using modified graphs. So if we look at this, we have our balanced equation. We have carbon monoxide, CO, plus 2H2, yielding CH3OH. And don't worry about the states for these problems. Now, we set up our table like we've done in the past with the mass relationships. So we have N for the amount of substance, or the moles, mass, lowercase m, and molar mass. In this question, we're told we have 9.8 grams of carbon monoxide. And we're told that we have 1.30 grams of hydrogen. Now, I took the liberty of filling in the molar masses. So the molar mass for carbon monoxide is 28.01. And to do that, I just added up the molar mass of carbon and oxygen. So 12.01 plus 16. Here for hydrogen, I filled in its molar mass. So it's 1.01 times 2, which gives you 2.02. Notice that we're not multiplying by the coefficient here for the molar mass. It's just the molar mass for the substance that's specified, which is H2. And the molar mass for methanol, CH3OH, is 32.05 grams per mole. Now, in here, we need to go and take those masses and convert them to moles, because it's only through moles that we can work our way through a balanced equation. So we're going to convert these using our equation N is equal to mass divided by molar mass. And we're going to do that for each of the reactants. So here we have carbon monoxide. So we're going to divide 9.80 grams divided by 28.01 grams per mole, and we get 0.34988 moles. For N of H2, we took 1.30 grams divided by 2.02 grams per mole, and we get 0.64356 moles. Just like we've done in the past, we will be carrying extra digits, and I typically recommend that you carry 2 additional digits. Now, I filled in the information that we just solved for on our table here. So we have 0.34988 moles of carbon monoxide and 0.64356 moles of H2. Now we're at the exact same point that we were in the last lesson, where we were trying to identify the limiting reagent. We have the amount of moles of 2 of the reactants, and we need to figure out which one of these 2 is going to limit the reaction. Which one of these is the limiting reagent, and that's the one that's going to be completely used up and determine how much product is going to be generated, and which one's going to be the excess reagent, meaning that it's going to be left over once the reaction is completed. So we're going to have to identify that limiting reagent. And we can choose one of them and try to figure out how much of the other we would need. Now, it doesn't matter which one we choose, but for this scenario, I decided to solve for the amount of carbon monoxide we would need. So looking at this, we have our mole ratio. We have a 1 mole of carbon monoxide to 2 moles of hydrogen. So if I'm trying to solve for the amount of carbon monoxide that we would need, we're taking the amount of hydrogen that we actually have in this experiment, which is 0.64356 moles of hydrogen. And now we're multiplying it by 1 mole of carbon monoxide, because that's the one that we want to get. And we're dividing by 2 moles of H2, which will cancel out our H2s here. And we get 0.32178 moles of carbon monoxide. Now, this number here is the amount of CO that we need. And what we need to do is compare that with the amount of CO that we actually have in this experiment. Now, what do you notice when you look at the numbers? We have more CO than we actually need. So that would make carbon monoxide the excess reagent and hydrogen the limiting reagent. Now, like I said before, we do need to write out a statement to communicate who the limiting reagent is. So I'd like you to take a moment to do that and pause the video. Once you have it, an example statement that you could write would be, in this experiment, we would need 0.32178 moles of carbon monoxide to completely react with all of the hydrogen we have. However, we have 0.34988 moles of carbon monoxide. Therefore, we have more carbon monoxide than we need, making CO the excess reagent and hydrogen the limiting reagent. As I mentioned earlier, we could have solved the other way, and instead of solving for the amount of CO we need, we'd solve for the amount of hydrogen that we needed. It just the comparison would be a little different, but we would get to the exact same answer. Okay, now that we've done this, we're going to use our limiting reagent to find the amount of substance that's required. So in here, since hydrogen was our limiting reagent, we're going to use that to work our way over to solve for the amount of methanol that's going to be generated. And we're using mole ratios to do that. So we have 2 moles of hydrogen to 1 mole of methanol. So we're going in, solving for the amount of methanol. We're taking 0.64356 moles of hydrogen, and we're multiplying by 1 mole of methanol divided by 2 moles of H2. And that gives us 0.32178 moles of methanol that would be generated during this reaction. Now, the question was asking us for mass, so now we're going to have to use the molar mass to solve for the mass in step 5. So we're going to convert the amount of required substance to mass of the required substance. And in here, we know that N is equal to mass over molar mass. So mass is equal to molar mass times moles. So we have our 32.05, sorry for the typo here, times 32.178 moles, and we get 10.3 grams. In terms of sig figs, we were given 1.30 grams, which has 3 sig figs, so we're going to use that. I know in the question it said 9.8 grams. That was a typo, and let's consider that it was 9.80. Okay. So now we write and conclude with our statement. So when 9.80 grams of CO reacts with 1.30 grams of hydrogen, 10.3 grams of methanol will be produced. Now, in limiting reagent problems, the amount of the limiting reagent will always determine the amount of product that's generated. Okay, so we're always going to have to identify the limiting reagent when we're given the amounts or masses of 2 of our reactants. Okay, so as we're going through, like we saw today, we were given the masses of 2 of the reactants. We had to use molar mass to solve for our amount of moles. From there, once we had the moles of each of the reactants, we had to identify who the limiting reagent was using mole ratios and trying to solve for the amount that we need of one and comparing it with the amount that we have. And it doesn't matter which one we choose, we will still be able to identify who the limiting reagent is. Once we know the limiting reagent, we can use that and mole ratios to find the amount of product that would be generated. And from there, we can just use the molar mass to convert it to mass. I will be giving you some homework to practice working through these problems, and we will be taking them up in detail during our next live session. If you have any questions, please post them on the feed, and we'll try to work through it.